Hey guys. All right, that's loud enough. All right. Thanks for coming over. I know, did you guys, any of you been to the earlier talk with Charlie? Yeah. Yeah, it's crazy, right? And Black has just keeps getting bigger and bigger. It felt like salmon swimming upstream. Just so many people just walking up. So I mean, it's great. It's great for us. So, anyways, so this talk is about securing your big data environment, and a little bit about me. Uh, I'm Visa's chief security architect. The guys, you probably have one of our logos in your wallet right now, but uh, was involved with a couple other companies, insurance companies, and other tech companies. I did a couple startups before that. I'm also a co-author of Hadoop in Action book by Manning, and a couple of certs here and there. But anyways, one of the things I quickly want to reinforce on the topic itself. So big data means a lot of things to a lot of people, and I think so I mean, you guys saw the cyber stuff flashed all over in the hallway. People are using machine learning algorithms. People are using new streaming data from all over the place, and they're driving intelligent decisions or making intelligent decisions from that streaming data. So this talk is less focused on, I guess, what you might consider as threat intelligence or cyber analytics, and more on the platform itself. So more and more companies are pushing a ton of data into their big data environment. What used to be the mainframes moved into a bunch of relational databases in most orgs, and everything is converging into this massive data lake that's called big data. This talk is more focused on that, like how would you secure the platform itself, and what can you do with it once that goal has been achieved. So it's more on that. I'll do a bunch of threat modeling exercises. I mean, it talks through workflow, paints the risk a little bit better, and I think finally answers a couple questions on how can we actually go about trying to secure this platform? What can we do about it? And how do we effectively do it? So it'll be focused on that. And I'll be relating a lot, talking to my personal experiences, research, what I found was successful, what were some failures, hey, don't do this, sort of thing. And again, if you take a poll in the room and elsewhere, like you ask, hey, what's big data? You'll get like 100 definitions on everything. It means different things to different people. So just a quick level setting on, hey, big data just means it's extremely large data sets, or size and structure is beyond what traditional database systems can store and process. I'm sure you guys had experience where a dev team's like, hey, we want to spin up this Hadoop cluster or a NoSQL cluster, and you find out that their data size is maybe 10 megs in size, and it's an Excel spreadsheet. So again, it means different things for different people. I'm talking about NIST has a very good definition on what big data means, but I just want to level set. And um, what's Hadoop? And the reason I'm trying to pick on Hadoop is it's probably the most well-known association with anything big data related. It's the most common and well-used platform. So throughout this talk, I'll be intermingling the terms on Hadoop and big data, but it's ubiquitous enough that it should apply to any big data platform, any NoSQL platform you guys would have. So again, why would you want to secure this platform itself? Like I said, right, people are just moving stuff into these data lakes, and that includes you may have had like payment card data, or your medical data, PHI data, other PII, different country regulations, EU regulations, everything, and that stuff is getting shipped off to these data lakes. So what that means is, this is a platform that you would consider on par with any other data store you have in an enterprise. And as you might have noticed, I don't know how it happened in your orgs. If you have a big data platform, people are some couple guys say, hey, I heard about this thing. Let's spin it up, and before you know it, it goes from a POC to a dev to it's a production. People are just putting production data in there. So I'm pretty sure you have sensitive data in there, and another thing is, again, because it has sensitive data, it's subject to different regulatory compliance requirements. So all that PCI stuff, for example, that you have to worry about doesn't go away. You guys still have to do it if this environment has cardholder data, for example. And I think I like the third example, the third reason the most, and mainly because the way organizations are moving forward, the new environments or new techniques, like for example DevOps, or people are leveraging the cloud more and more. And what happens is you're not in a situation where, hey, I'm gonna design this waterfall method, and I'll have a bunch of requirements, and we'll plan and design and execute accordingly. We're not in that day and age anymore. Things are happening so fast. What I think, as security practitioners or people who are responsible for security in our respective orgs, what we want to do is support our enterprise on how can we allow this to happen. And the only way we can, in a way, allow it to happen is if a bunch of people are able to use it without worrying about too much controls. And what I mean is a big data platform is only as useful as the amount of analysis you can do. And the amount of analysis is directly related to how much data sets can they access. And the second you start putting constraints, whether it's crypto, access control, whatever it is, some of the value proposition starts to go away. So you want to expose this platform and secure it at the same time, so you can kind of minimize those concerns. Because even if you just go back maybe 2-3 years ago, when this ecosystem in general wasn't considered secure, the only thing you would ever find in there was non-sensitive data. Maybe people just threw in test stuff in there. Anything non-sensitive used to be in there. And I mean, you're not really leveraging the platform, but you guys heard Charlie's talk and some of the other talks here. The Internet of Things is a real thing. So what that means is you'll have more and more devices sending extremely sensitive data. So for example, in Charlie's talk, he was hacking cars and any moving vehicles, but if you go back, maybe some of the insurance companies, for example, they do it. They stick in those readers that's capturing your vehicle information, how fast you're going, sensitive stuff that eventually comes back somewhere. And the only way you can run effective analytics is expose it to the platform. So, and vendors in this space, they do a pretty decent job, and sometimes they just come back and say, hey, we don't lock you down, we expose our APIs, we expose our platform, everything is open source, so you can just hack away as whatever you want and just customize the platform like how you see fit. So, and you look at it, and when they say, yeah, hey, it is open source, it just, again, it's not true. Most of these guys, they have taken open source, Apache, and they augmented it, they customized it, because all these vendors, they're for profit. What they do is they augment the solutions, take the native code base and customize it, and then package it and resell it out to enterprises and everyone else out there. And why that's important, and I'll give you guys just a couple examples. So CVE, most of you guys know what CVE is. Um, if you go back and look at the CVE database, there are only four reported and fixed findings in the past 3 years. Now, that's a significant metric for your risk folks, for example. I mean, yeah, what that means is, if you go back to the old Microsoft days, right? Microsoft had a bunch of bugs, but they weren't published as CVEs. It was all closed source. The vendor found it, and they did a bunch of things. They patched it, and no one was the wiser. But I mean, this is reflective. I mean, if the ecosystem is truly open source, where are the bugs and who's fixing them? So something to think about. And if the traditional RDBMS systems that used to house a lot of your sensitive data, they went through like literally decades of rigor. Like I mean, we can make fun of again Microsoft all day long, but since they adopted SSDLC, the SQL Server platform only had one finding, one significant issue, and I think that was also in a shared library. So now you take that back and look at all these patchwork of what you would consider as a Hadoop ecosystem, and then your surface area of exposure just increased, and it's unknown. And the last thing is there's absolutely no standardization. I mean, you can make out who the big vendors are if you're trying to get a package solution, or if you're trying to get a true open source Apache package, but there's no standardization. And what I mean by standardization is we talk, hey, we protect your data at rest, or we take care of this IAM layer, but everyone does it different. So the day you shift a vendor, it's truly hard to do that again because there's no standardization. And some metrics, right? This is the latest data. Where's OPM? Yeah, it's there on the far right. Just this past year, the amount of data breaches, and I want to flash this metric real quickly because it just shows how much data is getting breached, the volume, and you can bet it that most of these orgs, like, hey, we got breached because of this Oracle exploit, or Java, some middleware exploit. Let's just push everything to Hadoop, and we'll be secure. So I mean, just think about it. The today, I think in a way this platform is just about ready to take off. We're at that tipping point. So what that means is, I mean, as security practitioners, right, we always think, oh man, I wish I inherited a greenfield environment. I think this is one of those rare situations where we didn't truly inherit a greenfield environment, but we're pretty close to the starting point, and we can do a bunch of things that may not be possible before. So secure the platform and wait for the enterprise to push data into your environment. And just again, Verizon metrics on how fast it takes attackers to compromise. I don't know if you guys read the latest Verizon report, but 60% of the cases, it just an organization was breached and data exfiltrated within a couple minutes. So that's a significant metric. And if you think about it, like if data was fragmented and your sensitive data, what you care about is all over the place, and attackers have to do the recon, they're trying to traverse your environment. Now, guess what? You just made it easy for them. Everything is in a central place, just one place, everything. So the problem is significant. The challenges will only increase. So something to think about. Yeah, it just definitely escalated. And attacker, right? Like, I mean, what are they thinking about? They just want to get that sensitive data, different kinds of stuff. And some of them try to think, hey, maybe they're more, I'll try to damage this environment, or things of that nature. But I mean, there's a finite set of things in the universe that an attacker wants to do. they want to gain access to your sensitive data. I mean, even if you think of the whole attacker ecosystem, right? I don't want to generalize an attacker, and especially in a place like Black Hat. But if you think about it, there are probably only three segments. One is the guys who are trying to break into your environment because you have maybe some monetary or some financial relevant data that they can take out, reuse, and get some financial gain out of it. Then a second set where maybe this more falls into the nation state category, where maybe you're a defense contractor, you have something very sensitive from an R&D perspective, and they just want to take that. And then the third category, the lulz, they just do it because it's fun, right? But as a defender, I mean, this is a defense talk, right? Like, if you boil down your problem statement, if you know what data is in your environment, then you can identify who is a potential category of an attacker who will come after you, so you can start to plan your defenses around it. I'll quickly run through this. Different types of attack categories. Some at the IAM layer, at the network layer, at the host level. Cryptographic protection address. We'll hit some of those a little bit later, and infrastructure security. Over the next couple slides, I'll just quickly run through a typical what I have seen through my research. Like, if I have to generalize, hey, what does a typical big data environment looks like? So I'm going to run through this. So, and this is this looks like this is a threat modeling exercise. I think I'll run through it quickly. And just as an FYI, there's a lot of stuff, gory stuff, in a white paper that will be part of this talk. So, definitely read through that. So, just a typical environment, right? You have an external entity, maybe it's a partner or a customer who's trying to get into your environment, so you have an external internet-based attack vector. Then, maybe you have some sort of a corporate trust boundary where you're collecting all the messages. Maybe it's a REST or a SOAP message. Maybe there's some sort of a bastion host or a proxy where you're aggregating and collecting events. Then you have your corporate users, the guys who actually use the cluster, do a lot of stuff, or maybe there's an external user trying to do a bunch of things. And I just put in a random sampling on enterprise directory, like maybe there's some business intelligence clients that are running some analytics jobs, other IAM components, Active Directory, Kerberos, etc. And so this is important. I just want to flash through this a little bit, because one of the things that is asked quite a bit is, hey, I'm doing my research. We're just starting to get into this Hadoop or the big data thing, and I did a comparison of all the vendors in this space. But I really like the features of this one guy, but I really like the features of this other guy. What do I do? And you obviously have the cost and the pricing decisions, and some might say, hey, this platform is this vendor is very true to open source. Everything is as close to open source as possible. This other guy, they customize the heck out of it, but they have a lot of security controls that I think I truly want to leverage. So, why I kind of wanted to flash this a little bit is at the end of the day, I think it's a good thing to think that it's okay to segment your clusters. Have one cluster in maybe some sort of a more trusted boundary where all your sensitive stuff is, and another where non-sensitive data. And the clusters can talk to each other, and we'll talk through a bunch of techniques a little bit later, but it's okay to have a multi-vendor, a distributed environment doing exactly the same thing, as long as everything's sharing some sort of a crypto bus or an access layer. And again, different ways people connect to your environment. We saw the corporate users. You have your typical applications, internal apps running, ETL jobs running through different ports and protocols, HTTPS, web services, different ways to connecting. You see this guy at the corner, intentionally put that in. Like someone's, when you look at the overall threat model, a lot more is in the paper, but people like, no, let me see. Yeah. So this guy here, like this is a corporate user, and they're SSHing into your restricted zone directly into the client machine, and they can access your cluster and run jobs. So I think the picture's kind of okay here, but this, what I'm painting here is probably a pretty good baseline implementation of most big data environments. And the threat model is, go through the protocols, the access layers, the crypto layers, all that fun stuff. So finally, this framework has evolved just in the last couple of years. We've been spending a lot of time on this, and each of these little boxes represent a control or a control category, things you can do or want to think about. Some of it is data management, IAM layer, the typical data protection stuff, the network security, and infrastructure security. I'll highlight some of these controls more than others, just because I think they're probably the most significant and most value for Buck. Here, what I'm painting, so remember, like I said, you want to know who your attacker is, but I think probably a better exercise, if you guys are getting started, is just the data classification exercise. And you probably did it in different shapes, different fashions. You have a whole team doing some of this work. But if you think about it, right, like, why would we spend time and energy and controls protecting data that's probably not important to us? And of all those data types, which one's the most important? Because the day you start this exercise, the first thing that an executive will ask is, okay, that's great. So do we have like 60 fields that we want to protect? Oh yeah, okay. So would you cryptographically protect or encrypt every one of those fields? And hopefully the answer is no, because there's no way you can start a project or a work effort saying, yeah, I'll protect 60 different fields across 10,000 databases in my environment, for example. That will never happen. So what this truly is a prioritization exercise. And I have some, again, more details on the paper, but just a quick glance again, the final score, how I'm calculating it is likelihood and impact. So what control weakness, the first column is, can I apply cryptographic control on this data field? So there are some scores around it. Then there's a value to an attacker. So there's some data that it's easier for an attacker to resell. So credit card data. It's very easy for them to resell it on the black market. But if I have the blueprints, the latest Apache helicopter, from the U.S. Navy or something, then the value, there's no resale value. The motives are different, but what's the value to an attacker? There are other fields like the OPM hack. Most of the things that people are worried about is they can make for very effective phishing campaigns. So if I'm a customer, right? Like if you think about it, if some entity out there gets breached and they lose my credit card data, yeah, yes, that's impactful. But as a customer, the first thing I'll do is, okay, I get the notice, I call my bank, say, hey, can you reissue my credit card? And 2 days later, I get a brand new card. Definitely there's a pain because I have to go change some of the billings and the online logins and stuff, but it's okay. But if I lose an identity, like say my email address, as a consumer or individual person, I have that's more impact to me. So and I talk about that at the impact to the customer itself. Then there's different other fields like hey, if I lose this field, I can't do business, blah blah blah, and you finally end up in a good score. And I have more details on how you guys can do this assessment in your own organization in the paper. So definitely catch up there. So just going through the control categories real quick, right? Like I want to highlight this feature, like on that first row. This is probably the most effective one, discovery. And the reason I say that is, I talked, hey, there's a bunch of data coming in. Now, for you to do anything to protect it, you need to know exactly where that data is. So for example, like think of a typical like data is coming in, getting dropped in a cluster as a file. Maybe it's a comma delimited or a sequence or a Parquet format, whatever your favorite format is. But if you know that, hey, this is a particular column that has, say, credit card data, maybe I want to tokenize it, or maybe I want to encrypt it. Unless you know what you're trying to protect, it's hard to do the protection control on it. So you have to start with this exercise. The other value add that this really gives you is, for example, if you tell an executive, hey, I just have, a 10 billion records of extremely sensitive PII data, you show that incentive to your executives to get stuff done. So it's good from getting the money, and it's also good from trying to actually implement the controls themselves. And data tagging. Anytime you can tag anything upstream, it's the most effective way. So I listed some typical methods. People just drop data and take data out. Why this is important is, you start thinking, okay, again, the notion of a kill chain is pretty well known in our field. So you have to assume in a lot of cases that an attacker or a bad guy is already in your environment. So okay, that's fine, but the true impact to you happens when they leave with that data, and and there's a compromise. So it's all about trying to break the kill chain. Where do you focus your time and energy on? If you go with the assumption that an attacker is already in your enterprise, what do you do? So what I showed here are some very typical. I think I probably covered about 90% of the methods that data just gets dropped in this environment. So again, it's all about trying to funnel your problem statement. You have your attacker classes. You know what your sensitive data is and what's important to you and what you want to protect. And then you know what the typical ingress and egress methods are. You can start laying the rules on how you want to protect this. So we talked through this summary. Oh, some gotchas, I guess, is one of the things you probably will discover as you're going through some of these exercises is you realize, hey, why is our cluster compressed with gzip? Who did that? Who took that decision? So just some of the things to think about. I mean, maybe they're thinking about it from a storage, but storage is so cheap. Like I think Amazon charges a penny for a terabyte or a petabyte. I don't know what that metric is now. So storage is very cheap, but as you start putting data in your cluster, whether it's running security jobs or maybe it's your devs running any of the analytics, it's all about I/O. So small things like this matter. And also because that discovery thing I just talked about, when you run a job, it runs as a job on the cluster. So you have to decompress, run your job, and then push it back in. So if you have a petabyte and you're compressing it 6 times, it's 6 petabytes now. So something to think about. Another thing, and it's tying back to that classification chart, right? So it's something in the financial industry. If I'm an attacker and a table with just credit cards gets breached, it's a big deal. But if you look at it from a pure attacker perspective, it's useless to them. Because, I mean, think about it, right? Like you go to, say, Amazon or you go to any e-commerce site, can you buy anything with just the 16-digit or the 15-digit credit card number? No. You need other attributes. Maybe it's, you in the United States at least, you plug in your credit card, you enter your 5-digit zip code. That's a secondary value. Maybe in an e-commerce site, the things that get asked is, hey, what's your three-digit number at the back of your card, or what's your expiry date? And the reason I'm bringing that up is, again, trying to funnel the problem statement in your cluster is, okay, great, I just found all the credit card numbers, but what's the value if, you want to start doing conditional grouping. If I find a record with those fields, maybe card number and zip code, or card with CVV, that's more important to me as a defender. That's the one I want to truly protect first, and maybe I'll come back to the rest later. So quickly running through it, I am, again, user entitlement. There's a bunch of things and techniques I think you want to do. I listed some tools, Apache Knox, Apache Sentry, open source. You can start putting it in your environment. The big thing I want to focus on in the IAM section is key tabs. So a lot of people don't realize, like, maybe some of you guys do, but key tab file, like, it's just, it's your password. You get your after you get your initiate the Kerberos ticket process, and why I think that's important is, from an attacker perspective, right? Like, think of it. If I log in using a regular Unix account to my Hadoop cluster, now, and then I run SU to get privileged credentials, that's not a problem. I mean, that's part of normal operations. You want SU sometimes to do some jobs. But now, what if you extend that threat scenario to say, okay, what if remote login is configured on all these systems? Now, to effectively do that, you probably have some sort of a passwordless SSH keys going on. So what happens is I go in, I SU, and once I'm in there as an actor, say I'm a malicious actor, I can go switch to my root directory. Then I have complete access to my all the private keys for root. Then what if I'm navigating to other servers in the cluster as root? And now, because I have complete access, I also have access to all the key tab files in there. So now your typical attacks, like pass the hash attacks, I can do it. I don't have to decrypt any of the key tab files. I can use that existing key tab files and start impersonating someone. Maybe I create a secondary account. The only time there's audit trail back is the first time I logged into that cluster, and after that I'm gone. I'm anonymous. So really, I think this is probably one of the most important things we want to focus on. Really protect those key tab files. Crypto protection, different layers, different methods you can do it. It's pretty typical application level. I talked about it. At the HDFS level and the disk level. Now, the quick 10-second summary on this is, if you have a large existing cluster with a ton of data, and maybe it's PCI compliance, cardholder data, the first thing maybe you want to do is do some sort of a transparent encryption, encrypt at least your disk. So it's not like, again, it's transparent, at least it doesn't truly protect you against certain attack vectors, but at a minimum, because it protects the underlying file system, and if you leverage an external key manager, those key tab files that I just talked about are now encrypted, and an attacker also needs some method to fetch keys from an external key manager. So it just separation of duties helps there. From a protection perspective, a bunch of methods, but I'll highlight my favorite, tokenization. You guys heard about it at other places, but for your cluster, right? Like, as you're trying to think about protection, if your BI tool is expecting data to come back in a certain format or a sequence, what you don't want to do is maybe break it all of a sudden. Maybe a nine-digit field that's sensitive just turn into a 128-bit or a binary sequence that's coming back. So how can tokenization, I think, is probably one of the most effective cryptographic techniques, and I think some people call it format preserving encryption too. I mean, for me, I'm just collapsing everything as some level of format preserving crypto, whether it's tokenization or encryption or whatever it is. I highlight some things like um, the FPE standard is not fully baked in. It's you know, NIST has it in the final revision. There are a couple finalists, so it's not fully baked in as a standard. So just something to think about. Just running through, most of the clusters have AES-NI, so if you have that, just truly leverage it. Performance seriously drops from, say, 20-25% overhead to single digits. So, I mean, if you, again, right, like that 20-25% overhead, it's not a small problem anymore. Everything becomes a big problem in your big data cluster. Because you probably have to stand up a whole new rack with I don't know how many terabytes of memory and storage and everything else. So just yeah, that's really important from a cost perspective. Network security. So the good thing is almost every single distribution out there now has native TLS capability. So again, there's well-known published techniques that data in transit or TLS protection. If anyone says, hey, you know, yeah, I don't want to do it, there's an overhead. I think one of the most effective ways I found it to sell it in orgs is and it's probably true. I know if someone disagrees, please come talk to me after the meeting, and we can chat a little bit more. But you know, when we do TLS, I think the confidentiality attribute is less interesting to me, but the authentication piece is a lot more interesting, and especially if the way if you protect all your data at the application layer, if everything's protected. You know, some people start thinking, hey, is there a double encryption? Is there a double penalty? But the authentication piece is probably the most important aspect for me, I think, when you use TLS. So, um, yeah, some summary. Oh, on the infrastructure security, this is one thing I really want to highlight. If you look at every single vendor out there or a distribution, they tell you straight up, we do not support SE Linux. I mean, SE Linux is cool. It's really awesome, and why I say that is, you know, it's all about enforcing that mandatory access control. And a quick example: once you start labeling and enforcing that access permissions, not think about it, right? Like how like you guys been to all the talks today. Someone's popping a shell somewhere. They're pushing an exploit, maybe in a temporary location. Now, what if you know that that temp location or certain places only have read and write access, but they don't have execute? Yeah, you know, again, attacker can come in, they can hang around your cluster all day long. But if there's nothing they can do from an exploit perspective or exfiltration perspective, maybe that's a good job. If there's a well, couple takeaways, this is definitely one of the things I would strongly urge you guys to take a look. See if you can run SE Linux in your turn it on, turn on you know, the permissive mode. Start looking at all the logs, the events, all the warnings, and see if there's something that makes sense, and start enforcing it, because you'll find so many low-hanging fruit. Like for example, I found like a couple things that that's generating the crypto seed is running in a more privileged daemon when it's not supposed to, because it just inherited the native Red Hat policy. So just all those low-hanging fruit you can effectively knock out. And finally, visualization. So this is great. Like this, what I wanted to show here was, you know, it looks like I don't know, a solar system or something. I don't know. But what it actually represents is those big dots in the center are actually like, remember that data discovery and the labeling exercise you guys did, and then doing the enforcement and the access control piece. Once you do that, what you'll end up with is these clusters. So remember that problem space prioritization. How do you do that? The guys at the middle represent the most riskiest. they have the largest data, and they have probably unfiltered access or more unfiltered access than other aspects. So if you want to at least start focusing on some domains, these are the ones you start fixing, fix at the center and start going out. Some future work, like I said, there's a book in place, and there's a white paper that I think will get published shortly. So please read at it. You guys will have my contact info is there. So definitely ping me on any questions. So recap. Understand your landscape. Definitely do your discovery and classification. Use Kerberos. Protect your key tab files. Encryption, there's a bunch of ways and techniques you can do it. New data, use HDFS layer encryption. Existing data, use your transparent encryption. And if you're more mature, start doing application layer protection, encryption, tokenization, whatever suits your needs. TLS, and then data exfiltration. So that's about it. And definitely share your feedback. I think you guys will get an email or some alert. So definitely share your feedback. Always looking to make this better. And if you guys want to see anything, definitely let me know. So with that, I think so we're done. So questions, comments, feedback, anything? I could have shown a couple more slides then. All right. So I'll be here. So definitely come reach out to me if you guys have any follow-up questions. Thanks.